Most of the problems are being solved through machine learning. This is because we have a lot of data available, so availability of the data is not a problem. Computational capacity today is very high, therefore it is quite possible to implement the machine learning in solving any of the problems. So today most of the bigger problems we are now trying to solve through machine learning. So let us take one example. Write the use case diagram for the machine learning system or the problem which we are trying to solve through machine learning. So the first step is to identify the actors. The actors here may be the data scientist who builds and trains the models, and we have ML engineers, that's a machine learning engineers who deploys the models and monitors the models. End users or the application that consumes the model's predictions, gives input to the model and request for the predictions. And for all training the model we do require data, and the data is available from the data sources, so that provide us raw data, and of course some admin that manages overall system access and all that. To identify the use cases, one use case is to collect the data, because the whole system works on the data, so the first activity whatever we do is collect the data. Then data may not be the way we want it, so we need to pre-process the data, and then we need a model, and that model will be trained using the pre-processed data. Once the training is done, so we want to verify whether the trained model is fully useful or not. So for that we need to evaluate the model and then deploy the model and start using the models to make the predictions. Once we are using these models, the model need to be continuously monitored for its performance, and if we find that the performance is falling down, then retraining, adding new data and all this has to be done. So that's another use case we have. And if the model is not up to the mark, in any time if the model performance falls below something, then we need to update, or even we need to retrain everything from the scratch. So that's another use case we have. And the admin will be allowing access for the users and all that, so managing the access users taken care by the admin. So that's another use case we have. Data scientist uh, is a actor who is responsible for collecting the data, pre-processing the data, training the model, evaluating the model. The ML engineer is responsible for deploying the model, monitoring the performance, updating or the retraining the model. The end users is used to make the predictions, and the data source provides the raw data for our training purpose, and admin manages the access and the users. So looking at the relationships, so we have one improved relationship between the trained model and the pre-processed data. The model can be trained only when the data is already pre-processed. So before pre-processing, training the model should not be taken up. Therefore, the trained model should come under pre-processed data. That means there is an include relation between the trained model and the pre-processed data. Whereas we have an extend relation between update model and the train model. So looking at all that, so we have this use case diagram. So we have the use cases like collect the data, so that is the responsibility of the data scientist, and the data comes from the database. Pre-process the data is done by the data scientist. Define the model, done by the data scientist. Train the model, done by the data scientist, and evaluate the model by the data scientist, whereas the ML engineer will deploy the model and then will keep monitoring the model performance, and if it is degraded, then it will be updated. And this there is an include relationship here, so it says that the train model is possible only when pre-processing is done, whereas the update model will be the extended form of the train model, making use of the make predictions, and the admin is responsible for the manage access. So any common machine learning system looks something like this, which somewhere data is to be collected, pre-processed the data, a model is to be defined, training the model, evaluating the model, and continuous monitoring of the model, deploy of the model, updating the model, and the user is going to predict the results for whatever query the user is currently having. So that's a use case diagram for a machine learning system.